Hi students, this is AJ sir. Let's study 9th standard ICSE Math, exercise 2D. Now in question number 2, the value of depreciation, the value of a machine depreciated by 10% per year for 2 years and then 15% per year for the third year. Express the total depreciation as a percentage. It will be wrong to simply say that the total depreciation is 10 plus 10 plus 15, 35%. No, that's not how we solve. So first we'll assume the principal, that is the actual value of the machine, as rupees 100. Then we find the depreciation using the usual formula of compound interest. And so the amount after depreciation, remember there's a subtraction here. After 1 year, it's 90 rupees. Now for the second year, the depreciation is 10% of that is 9 rupees. So now the amount after second year is 81 rupees. You see, the value keeps on decreasing since it is depreciation. And in the third year, 81 is the principal. So now the rate has changed for the third year, 15%. So the depreciation for the third year is 12 rupees 15 paise. So the total depreciation is the addition of the 3 years depreciation, which is rupees 31.15, and the percentage is 31.15%. Now in the fourth sum, the principal is not given, the rate is given, and they have given us the total compound interest of the first year and of the third year. So we'll assume the principal to be rupees 100, and then we'll calculate the compound interest as 10. For the second year, the amount becomes the principal. Calculate the compound interest as 11. So the amount at the end of the second year is 121. This will become the principal for the third year, and the compound interest for the third year is 12 rupees 10 paise. So the compound interest for the first year and for the third year totally is 22 rupees 10 paise. These are the assumed values. So when we assume rupees 100 as a principal, we get the assumed addition of these two compound interest as 22.10. But the actual addition of the compound interests of first year and third year is given as 2652. So what is the actual principal? We will use unitary method to get the final answer as rupees 12,000. Now remember that in all these sums of chapter 2, we may use the formulae which we will study in chapter 3 as well. Now cancel questions 1 and 8, which are very easy. In the sixth sum, the principal is not given, but the difference between the simple interest and compound interest is given as 64. So again, we'll use the 100 and the unitary method. Let's assume the principal to be 100. So the simple interest for 2 years is 16 rupees. And the compound interest for the first year and second year will totally be rupees 16.64. Obviously, the compound interest will be more than the simple interest. So the difference between them is just 64 paise. But this is the assumed value. So when we assume the principal as 100, the assumed difference between the compound interest and simple interest after 2 years at 8% per annum comes to 0.64. But the actual difference is given in the question. It is rupees 64. So if you cross multiply and calculate, you get the final answer, that is principal is rupees 10,000. Make sure you show all the calculations. Just don't copy from here. Now mark the ninth sum as IMP. Here the principal is given as 12,000, but the rate is not given. After 1 year, he paid back rupees 4,000. And then the compound interest in the second year is rupees 920. So since the principal is given, let's start with that. Compound interest will be 120R, where R is unknown, the rate of interest, and that is what we have to find in Roman number 1. So the amount again will be principal plus the compound interest. Now this amount of the first year should be the principal for the second year, However, at the end of the first year, he repaid 4,000 rupees. So subtract that from the amount to get the principal for the second year, which comes up to 8,000 plus 120R. So in the second year, the interest will be calculated on this principal, and the interest has been given for the second year as 920 rupees. But let's find the value of the compound interest using the formula. So PRT upon 100, on solving, we get this expression. But we know that compound interest for the second year is given in the question as 920. So substituting that value and cross multiply, we get a quadratic equation. Let's divide the whole equation by some common number to simplify it. The biggest number I can divide the whole equation with is 40. So after dividing by 40, I get a simpler quadratic equation. Now how do we solve the quadratic equation? By splitting the middle term. I have to split 200 into two terms such that the product of the two terms will be the same as 3 into 2,300, which is 6,900. So this can be done in the rough work. Suppose I have 6,900. Let's try to split it. 3, 2,300. 2 ones are 2s are 5 0 ones I said. Two 5 carry forward 1 15, that's 7s are 14, carry forward 1 and 5. Now it won't go by 2. It won't even go by 3. It will go by 5. 5 ones are 0. Don't forget the 0 here. I'm sorry, 5 ones are, and then again 5s are. 5 ones are. And then 25, 115. Again 5 2s are, and 23. And 23 is a prime number, so 23 ones are. So I need some combination from these factors such that their addition gives me 200, that is addition or subtraction gives me 200, and the product is 6,900. Now let me check out all the pairs. 3 into 2,300 is one possibility. Then 3 2s are 6. So 6 into 1150. Then 6 into 2 is 12. So 12 into 575. Into 5 is 60. So 60 into 115. And into 5 is 300. So 300 into 23. And finally 6,900 into 1. These are the possible combinations. Now I noticed that here there are more combinations possible. What if you take 23 into 5 into 2? So that gives me 230 into 5 into 2 into 3 is 30. So 30. So we have to check all possibilities here, all the permutations and combinations, and this seems to be the appropriate combination, because 230 minus 30 will give me 200 and 230 into 30 will give me 6,900. And be careful about the signs as well. This should be positive and this should be negative, because only then will I get 230 minus 30 as 200. Now the more sums you do like this with quadratic equations, the faster you will be at solving such sums. So we have split it into two parts, 230R and minus 30R. Check. 230 minus 30 is 200 and 230 into 30 is 6,900. So this is a perfect combination. Now take common. This is one group and this is the other group. Here only R is common, so take it out common. What is left behind? 3R plus 230. That is in one bracket. Now here take minus 10 common. So what is left? 3R plus 230. Since minus is taken out common, the inner sign will change. And of course, this bracket and this bracket should always match. That's a big hint here. Now the brackets, write it once common and the remaining terms in another brackets, they are equal to 0. When the product of two brackets is equal to 0, that means either of the two brackets has to be 0. So either this is 0 or this is 0 or both. Now if this is 0, solve and get R alone. I'm getting a negative value which is not allowed. Rate of interest cannot be negative under normal circumstances. But here the rate is positive 10%. So that's a final answer. For Roman number 1, rate is 10% per annum. Next in Roman number 2, they've asked us to find the amount after 2 years. Now you can use some formula, or we know the principal is 8,000 plus 120 R. That's what we had written here, principal. And now that we know the value of R, I can find the principal for the second year. And amount is nothing but the principal plus the compound interest of the second year. And compound interest for second year is already given as 920. So just add then, substitute R and get the final answer as 10,120 rupees. So mark this sum as IMP.